Let's see. We could put the chat maybe. Why it doesn't go right down all the way? That seems odd. Okay. All right. I think we're ready. We can drink coffee. All right, so I'm jumping straight in today. It is a little normal than usual for anybody who hasn't caught me before. I don't know if we'll have anybody new, but in case you are new, typically on Saturdays I'd be streaming at a couple hours ago, about 6 hours ago from right now. So I'm a little later today than usual, but had some other stuff going on this morning. So now we're gonna be doing some streaming. We're gonna be working on some CircuitPython stuff. I did say last night I'd be continuing on with this web workflow thing. The truth is I actually did work on it a bit more last night after the stream, and I ended up getting it worked out. PR is in, so I don't necessarily need to do anything more on that. I did get it figured out. I think I had the free space already when we were on stream. We had hard-coded the block size, but I think I've figured out a way to look that up, although we should probably test it on some of those other devices, right? Because I still only did run it on one. Let me show you what that ended up being if anybody's interested who did catch yesterday's stream, or if you didn't see yesterday's stream and you're interested in this type of stuff, you could catch that on the deep dive VOD where I was working on it. For the block size here, I found this code somewhere else, and it ended up being pretty straightforward. We're able to create a block size and call this disk IOCTL. We can tell it the file system object. We can tell it this is like a command of what we want to do. In this case, it's like the get sector size command, which will return the block size to us, or sector size, which I think is the same, but I'm not sure. We give it the output variable where it's going to store the response, the result of the function. Basically, it's going to store it in there. So then on my device, 512 is what came out of there. So we're able to use that to multiply in order to find the bytes. For the total was a little bit harder, but the code to actually do it turned out being much simpler, ironically enough. The magic here was this thing, fs_in_fat_int, which I don't have any idea what that is or where it came from. But it turned out to have the size. So number of fat entries, there you go. Which works out to be the number of what they call clusters in here. The clusters are of this size. The method we found last night during the stream was the one that told us the amount of free clusters. We were able to multiply it by that size to turn it into bytes to get the number of free bytes. This then has the total number of clusters, or I guess the -2 is important as well. This whole equation here, but this is obviously the bulk of it. That gives you the total number of clusters, which we can also just multiply by the block size in order to get the total space. And that seemed to work out all right for my device, which was the Feather TFT. So there's an example of the response. I actually did stick the block size in there as well. I don't know if we want to keep that or not, if it's useful for whatever things are consuming the API, I guess. I don't know if they care about that or not. So yeah, if you have a preference on that, leave a review or a comment on the PR, but that's where we ended up there. So I'm actually going to jump into something different today, which is back to something I did a while ago. I made a tilegrid contains function on the tilegrid object. This was basically a function that allows you to easily test whether a pair of coordinates is inside the bounds of a rectangle, in this case the rectangle that the tilegrid represents. This API contains is used in the CircuitPython display button library. That's how you test to tell whether or not it's being touched, basically. Button contains P like this. This PR added that same functionality to tilegrid so that you can basically use the tilegrid as a button using the same API as this button thing. On this PR, back when I made it, Scott mentioned this group would be cool to do as well. So that is actually what I am going to look at today. Group, though, is trickier. Adding this for tilegrid was relatively easy because really all it does is some greater than less than math with the bounding box of the rectangle, the X, Y, top left corner, the width and the height. Those four values kind of make up a rectangle, and then we're just testing points to see if they are inside that rectangle, which is fairly straightforward. The group, however, does not know these values. Tilegrid, it was easy to add this to because Tilegrid already knows its own X and Y and its own width and height. Group, however, does not know its own width and height. And to be a little more specific about it, group doesn't really have a concept of width and height, which it will need to have some kind of concept of width and height in order to be able to make this contains thing work. Where is group? There it is. So it has an XY. We do have that part covered, but it doesn't have a width and a height. And conceptually, this kind of makes sense, and I think there's a diagram in here that does a pretty good job, if I recall correctly, kind of explaining why that is. Is this the one I'm thinking of? So for one thing, groups can have different scales. Groups can contain other groups. Not sure if that's actually the graphic I was thinking of. Maybe though, I guess. Tile grid. So like the way it's drawn here, you might think it does know its width and height, right? Because it's essentially, the display is kind of drawn as a rectangle here. There is one group that's containing all these other things. I guess that's this main group here, I think. There's a group inside of it, which contains a tile grid, another group inside of it, which contains a tile grid, and another group inside of it, which also contains a tile grid. They're at different scales, or at least the tiles are different sizes or whatever. They could be at different scales if you wanted them to be. But nothing today, right now, really knows the size of these rectangles, or I should say, the display has a width and a height. So the outer rectangle here, you can get width and height from display, but that doesn't really help necessarily because the group doesn't have to occupy the entire display. The group is really only as big as its contents. So it'd be maybe a better example to say like this rectangle here, which looks like a square, but I don't know if it is. Nothing inside display.io really tracks the size of this today. What we would need in order to do that is basically iterate over all the children that are inside this group. So if there's only one tile grid inside of here, it's not actually that hard at all. You just look at the tile grid, you know, the size and shape of the tile grid is basically the size and shape of the group. But where it gets more complex is what if there's, you know, 5 tile grids, or, you know, 2 tile grids and another group which contains some more stuff. You know, it can contain as many children as the person added, and those children can be repositioned. Those children can be groups themselves which contain more children. So in order to really know the width and the height, you would have to like iterate over all the children, figure out the kind of minimums and maximums of their left and right edge. And I want to start, I guess, I think just at the Python layer before. So like ultimately, I think this would be on group inside the core. But I do actually want to start on the Python layer and just validate some of my assumptions about group. For that, we can take one of these basic examples, maybe like, what do we want to put? Let's put our own stuff, actually. Maybe let's start with this one. Okay, this was a boundary fill speed test. Oops. Check that in. So this will, let's make some, do we need more colors? We don't really necessarily need more colors for the background, I guess. I do want actually white there. We really only need one, I think, for, we only need like one color for each bitmap, but we'll maybe have a few different bitmaps. Let's also actually do like red. I don't really need all the comments for now. Actually, not the ones that are wrong. Should we make a helper function? Let's copy paste. Okay. We don't want these all to be this size, though. We're gonna have 3 bitmaps. Each one's gonna have a different color. They're all gonna be on the group. Maybe should have made a function. Let's go down also, so like... Okay. To go down farther than that. Doesn't really matter. So the group we have right now has 3 tile grids in it. Each of the 3 tile grids knows its own width and height, but the group doesn't know anything about the collective width and height. In order for it to actually know that, I think what it basically needs to do is iterate through all the children and find the minimums, the minimum left edge, the minimum top edge, and then the maximum left edge, and the maximum bottom edge. Except, is Y backwards? I don't know. Boundary boxes for groups. Yeah, I think so. No, it's not the focus of my endeavor. Be excited to see group and palette inherit more list capabilities, particularly things like slicing. That would be cool. Yeah, slicing. It would be interesting to take a stab at. I've never implemented slicing inside the core. So we don't have direct, like if we had maybe, we don't really have like right edge, left edge, but the tile grids have XY, which represents the top left corner, so that is the top edge and the left edge actually. And then you have to do a bit of math. You would have to like x plus width in order to get the right edge. And you'd iterate through all the children, saving whatever is the lowest left edge, the lowest bottom edge, the highest right edge, and the highest bottom edge. And then after you've made it through all the children, those maximum values, those will basically represent the rectangle of your group. For item, I don't know. I mean, they're tile grids or groups. We'll worry about the other quirk in this, which is that a group can contain a group as well. So we would actually need to, like, if we found a subgroup, we would need to do this calculation for it in order to take it into account for the calculation for the parent one. I assume at some point we'll start to slow down depending on how complex your stuff is, but better than not being able to do it. I'm not sure if you can iterate like this. Let's start with just, does this work? Whoops. I don't know if we probably don't have TO open. Okay, that does work. Wait. Are those? Oh. Item. Yes, obviously. There we go. Okay. It's like, why are those groups? There we go. Okay. We have 3 tile grids right now. I'm going to worry about the tile grid case first and then worry about the subgroups. So we're looping over them. We basically want to say, we could create 4 variables. We could create a list. Create a dictionary. Edges. I'm going to go with a list, I think. I want to go like this, though. Nones. And then basically we want to go... So I'm going to say, I think XY, so that would be left, top, right, bottom. So if it's, I mean, we could say, is it better to say is none versus not? You basically need this for all 4 sides, essentially. Y goes up as it goes down. We want bottom edge is less than the minimum, basically, is the bottom edge. Whoa. The greater thans needs to be different, but let's worry about after we fix these, because if these are wrong, then we'll be broken in very strange ways. This should not be x anymore, but it actually needs to be x plus... x plus... It's not really width, it's actually width times tile width, actually. Item.width times item.tile width. So width is the width in tiles, and then tile width is the pixels in each tile, which in our case, there's only 1 tile. They're 1x1 tile grids, but obviously there could be more complex examples. Whoops. There we go. So if it's none, or if the right edge, which is the x plus the width in pixels, which is the width times that. If that's greater than the current maximum right edge, then store the new right edge, which is this. This is going to be very similar, but with y's. Item y plus item, whoa. We need to probably figure out, can stuff go outside the left edge of a group? Test that in a minute. Does it matter if stuff can go outside the left edge? Because we're finding... These aren't guaranteed to be unique though, right? These are group space coordinates. They're not display space. How's it going, Keith? Yeah, thank you. Hope the same for you as well. Yeah, actually, I don't know. These coordinates are going to be relative to the group they're inside of, I think, not relative to the screen, which throws off the left edge, right edge. Let's worry about that in a minute, I guess, though. We'll also need to test and make sure it's a tile grid, but we can do that later as well. We don't want to really do this in the loop, though. Let's go back here, do that, see what this looks like. 60, 10, 170, 120. Which looks pretty reasonable. I think that one does work in this case, the most simple of cases. But what if these were like... Did it rerun? It did, but... Huh. That's weird. I don't feel like it reset though, but it reran, but it's not updating the, yeah. It's not updating the display. I've been in this state. Yeah. We've been here. The display's frozen, but it doesn't know that. See, like, REPL doesn't take over either. I have been in this state a few times lately. I don't really know what's causing it. Yeah, see, ordinarily this would take back over. But like nothing knows, the code just runs and everything is cool. It doesn't have any kind of error or anything like that. It's not like, you know, SPY display in use or anything like that. It's just like not actually going to it some reason. 0. So I guess, yeah, I mean that's pretty fine. So let's do our negative. Well, we are on negative now, I guess. So this is going to scoot it partway off, and then we did actually already see that the edges do get set correctly. So that part is fine for now, but then what if we also have like... Yeah, so we need to also count for this. Which is basically we just need to add group.x to each of these. Well, x to the x ones and y to the y ones. Okay. So in order to see if this is actually working right, I'm gonna do some different stuff here. This group is actually gonna be test group. We're not gonna do this. Main group, new group. Let's say this will be called size debug? That's probably not the best name. I want a vector rectangle, but I don't know what it takes. Pixel shader. Let's say we're gonna put like some kind of gray, I guess. Debug palette equals new palette, only one. I wish you could... Do I wish that? I wish you could pass your colors here, maybe, so that you would not have to have a second line for this. Does it matter that much? Maybe not. Let's go like... something like this. XY width height. Should we turn it to a tuple before we return it so that it's not in a list still? Does that make it use less memory after the fact since you can't append and all that stuff? I don't actually know. Bounding box is, what did I call this? Group size? No? Yeah, group size. I think I cannot call it after like this. Does not do hoisting, maybe. Eventually this will not be just like a random function, but I want to get the functionality down before I dive straight into the C code where it's going to be way harder to troubleshoot what's actually happening. Group size of the test group. So then we say this will be bounding box 0 y 1. Width we need to calculate, I guess. Width it's actually 0, 1, 2 minus this. It's the right edge minus x. It's the left edge. Why are you mad? Unresolved reference. Did I not spell it right? Oh, I see. Messed it up there. I also messed it up here. Goodness. Do we need anything else? There's like index, but I think it'll default to the one we have. Show main group. We don't need this down here. Why is this? Group doesn't have iter? Strange. Okay, that's just like a stubs thing though, I think. We want to put the debug thing behind the test group instead of in front of it. Which means I think I want to have a debug group equals new group. Put that in first. Whoa. And then we'll put this in our debug group, which is behind our test group, and we'll show it. So we should have a gray box that surrounds everything. Which it looks like it does to me. But let's test some more stuff. If we move this back onto the screen, well, oh, it's stuck again. We should probably try to document this. But I don't know the exact... Oh! No, we're not stuck in that again. Oh, right. We're still negative because of this, though. Makes sense. Yeah. If we also did this on 0. Well, 0 makes it kind of hard, doesn't it? Well, let's see it anyway. On the left edge. And if group was 10, we would have a gap on the left. Yeah. Okay. One determination to make is scale. Which further affects this. Because these all stay the same, but now the actual space on the screen is twice as big, and therefore also not very visible anymore. And so now our bounds are too small. They represent only the scale 1 size. Scale gets weird though, because it doesn't affect the left and the top edges, only the right and the bottom edges. Would we just have to multiply the width by scale? Okay, so that one stayed the same, which is good. Okay, that runs off the edge now, which I think is probably correct. We would need I would need to use a bigger screen or smaller stuff to know if it worked correctly. Use smaller stuff. Not that small though. That's not quite right. think the box didn't change, did it? Did change, but not like enough to matter. Weird. Okay, so that's definitely not right. We need to multiply this whole thing? Maybe we need to multiply this whole thing. We could do it in line. Actually kind of like the idea of doing it down here though, because it sort of separates it out a bit so that we're not just having a longer and longer equation. Oops. Nope, that's not right either. Um, maybe we just go without scale for now. Uh-oh, now we're like ultra broken. Why are those so far down there, actually? It's not big enough, is it? The red one of these is at 010, which is here. It's 10 pixels tall, which gets it down to x20. There's only like half the width of that left, which is 5-ish more pixels, which means it only goes down to 25, but those are much bigger. And indeed, here we have 40 and 50, but then why is our gray box so small? How did whatever I changed cause that? Because all I did was take out the broken scale? We're still on scale 1? Are we? So, for one thing... Oh, okay, okay. Width... Yeah. This doesn't feel like the right size. Hmm. Height is 40. But the height of this red one is only 10. Do we have scale? Oh my gosh. Okay. Yeah. Okay. I don't know why I didn't check that sooner, I guess. I could have sworn I had already turned the scale back off, but that's not. I don't quite follow in my head the relation to the right edge with scaling. The right edge of this before any scaling is 40. What's the right edge of it after the scaling? Okay. It is just... So you have to calculate height and width and then multiply it by... Nope, that's not quite right either, though. The width is right. The height is not. But that's because... the group dot x is 10? But we're actually at 1010. Did we ever set the y? Maybe this should be... yeah. So scale makes everything a lot more complex. I think the next problem is the fact that well, I don't know if our gray box is drawn correctly. I guess so. Because what we want is like the smallest rectangle that contains everything that's in the group. Which is what we got. Oh, I think maybe scaling doesn't work right with vector IO. So we'd have to use maybe a bitmap instead of a vector IO. If we did that, then I think maybe we could just do scale 2 on the group, but that obviously doesn't really solve the root of the problem, which is we really need to find the actual bounding box in pixels. My geometry is not up to it, it seems. Feels like it would be multiply the something by the scale. That's where it kind of breaks down though. Because they scoot farther over, so like the location of the x and y also get scaled? Okay. Do we keep trying to make scale work, or do we just move on? That doesn't seem right. Well, I guess because scale is 1, yeah. It was 40 and 50. This made it 160 and 160. Why is that, though? That doesn't make any sense. Nothing in here does anything with scale. Oh, this is inside the loop. Okay. That's actually what I'm expecting, at least. It is feel wrong. It's weird, it looks like the X's are not aligned, but they actually are. The different colors kind of make it appear shifted. We're off by, like, basically what I assume is like 10 pixels. Means we multiplied one. Gonna go lurk, do chores, AFK, in and out. Nice. Sounds good. Yeah, it feels like we got one extra multiplication of the original width for some reason. Feels like, I guess we wouldn't want... Maybe we need this? We were inside, so we weren't accounting for item Y and item X last time I tried this way. And this removes our scale from the parent group's XY. We have to change it in both lines. Cannot only change it. We certainly cannot only change it in the if statement. I did it in the condition for one and in the effector for the other. So yeah, that was bound to fail pretty hard, I guess. There we go. Okay. And then this gap at the top is because the red one, we told it y is 10. So we told it that that's 10 pixels down from the top of the group. Therefore, we want to make sure we still account for that space inside of our group. I think? Or do we? Yeah. I think we want that space. If you didn't want that space, then you should just always make your top left thing be 0, 0. And you won't have the extra space at the top. Or where anywhere, honestly. I mean, this could be extra space on top and left if you did it like this. But these bounds are the x and y of the group. So yeah, I think they still should be taken into consideration when we're thinking about the bounding box of the group, because its x, y is part of its bounding box. You could argue, I guess, contains, when it's being used for touch, maybe makes more sense for only visible things. But this is kind of a different bounding box than the group itself. Okay. I don't need this. So it was the width times the scale, but we also wanted to have the items XY multiplied by the scale, which we didn't have the first time I tried it because I put it inside of here. This is where I guess the nope. Okay. Really, this is all if item Okay, so this one does get trickier. If it's a group, I mean, this could maybe be recursive, I guess. The good news here is that will have already accounted for the scale, so we can just use this, I think. I'm not actually certain. Do we need to, maybe we don't need to do these pluses? Yeah, I think we probably don't want these, right? Because they would already be factored in by this call here. Because eventually it's going to find the tile grids, and it's going to factor those in. Didn't really change anything at this point, yeah. Okay, let's start making this a little bit easier. Def. We have a easier way to make more boxes. That's still right? Yeah, definitely something doesn't seem quite right. Because we should, in this case, subgroup should be pretty much just 0, 0, 5, 5. These should be the bounding box of it at this point. Was. But we need still to factor in the parent group. This subgroup bounding box is in the coordinate space of the child. So it's 0, 0, 5, 5. But because our test group, which is, it's ultimately inside of our test group, is at XY 2010, technically we don't want to be returning zeros from here because nothing in our case, nothing should be less than the X and the Y. Technically, you can set stuff negative, which then more stuff factors in, but we don't have anything set negative, which means we shouldn't be getting values out that are less than these, and we are, and it's because we're not. Actually, it is because we're not factoring this in. Nope. But it would need to be doing this in here too? Needs to be doing that in here as well, I think. We're not actually doing here, and we probably should be. I'm so glad that I did this in Python code first. I don't even know that we're going to make it to the C code at this rate, but hopefully we'll at least have the algorithm written. We can then convert to C later. Plus... I think we would need them here too, but I'm not actually sure. There we go. Where's subgroup? Okay. I will be back in just a minute. Okay. So I think that this works now. Oh. No. Oh wow, now some of our original ones are outside. Oh boy. How did I break the tile grid part without touching it? X, Y, so the right edge. This is supposed to be right edge. But it's representing the width instead? I don't feel like the state of the code right now, we were already in and it worked, so apparently I'm just wrong about that though. We're back to scale 1, right? We're not adding the subgroup. Let's get rid. Oh, okay, maybe this is our problem. Oh wait, no, this was calling it here. I was gonna say maybe this is. I mean, we don't need to make this at all. I don't think this is part of our issue though. Hmm. Something's broken when these are moved. Yeah, because now the red one is poking outside of the gray box. Because we added these here. Hmm. Yeah. Somehow that's wrong, but I don't know the way to fix it. I've like accounted for XY in some places, but not other places, and that has kind of wrecked us, I think. Maybe we shouldn't be. Maybe we shouldn't be adding these in here, and instead we should just do the entire thing, get the edges, and then add X and Y to all of them? Not even worried about group yet. Again, we're back to not worried about group yet. No, that's not right. We're too far. Would you only need to do it on the X and Y? That leads to broken. Would you only need to do it on the width and height? Seems odd. I guess. I mean, it can't. No, it's definitely still not right because it's outside still. Maybe. Maybe that's what it's supposed to be right now, I guess. But I mean, definitely not at the bottom. The bottom and the right should for sure be aligned with this thing. The top, I guess, should be having a gap like it does because we put that first box at 1010. So that is making it inside the gray box by 10 pixels. But the we're basically 10 too far, but that means we would turn this back off. And now we're Feels like it changed by more than 10. Okay. I don't know. I don't think I have much more geometry in my brain right now, so I think I'm probably just going to call it a day for now. I feel like we're approaching what we need. I felt like it was working there for a minute, and then I went and added groups and started doing X and Y's. That has thrown everything out. Well, it hasn't thrown everything out, but it's gotten us a little bit wonky. I think that scale works as long as X and Y are 0. No, you know what's still something a bit wonky about scale about scale as well, actually, because on the small one here, it looks like the gray box is exactly on the edges of the colored boxes. But like we said here, this one is actually at 1010. There should be 10 pixels. Arguably, there should be 10 pixels inside that are gray, which aren't. And then once we have scale, we do actually have some number of pixels. Looks like 10, but it should be scaled up to 20 now too. Extract a JSON structure. The object parameters. I would say that's maybe better suited built on top of display IO at that point. And I will say I have made something kind of like that. If you're interested in layouts for, if you're interested in JSON for your layouts, check out this repo if you haven't. This one, I guess it's a little bit backwards from the way you're saying, like, if I'm understanding, you're kind of imagining taking the group and then being able to get JSON objects from it to go through. This one is kind of going the other way around. You take JSON and it builds a group for you. I will say too, also, this may be out of date. It's very possible it needs to be updated for some things to work. More of database solution. I gotcha, just a way to store it. I mean, this would kind of help you in that sense, because the core of the concept of this is basically expressing a layout, expressing a series of things on the screen as a JSON file. So, like, simple test is probably an easy one to look at. So you have this layout here that's inside of JSON, and it tells it like what type of view it's going to be. Tells it these are my list of subviews. Each subview has a type, has an ID, has an attributes like anchored position, color, point, all these things which are basically properties on the label. This one's an image, which will be like, I think, an image load. This one's an on-disk bitmap. So this library consumes this JSON structure and inflates it into a group and gives it to you so that you can put it in your own group or put it on the display or do whatever you want with it after that. And then you can still like look up stuff by its ID if you want to be able to do that. So like if you want to look up the label and then change the text that's on it. It's doing something like this. So it's going like, we inflate the layout, like this by creating an absolute layout, giving it the display, giving it the string which we read out of the JSON file, but it could come from anywhere. To your point, it could come out of the database or any other place. You pass that into there. That's basically giving you back an absolute layout which has a group on it. Basically, view is a group. Probably should call it group instead of view, truthfully, but that will show it for you, and then you can go like main layout, subview by ID, look up the view is kind of the term that I called them generically, but look up the child thing that has the ID main label, find the label object on it, and then set the text property on that label object. So this lets you kind of like build a whole layout in your JSON, but then in your Python code, unless you want to like change something, you don't actually have to have any code for any of your stuff. You can inflate it, put it on the screen, but not worry about this label's here and that image is there and this thing is over there and that thing. Instead, it's just like inflate the whole thing and show it. Only look up the ones that I want to modify something, then I can look those up by their ID and modify them. I don't have to keep a separate variable for them. Extracts group objects for database consumption. So you're thinking something basically would parse the group and spit out this JSON, essentially, kind of go the reverse way around. Which would be pretty cool as like a serialization, being able to go back and forth for sure. So I feel like I'm sort of close here. I think there's definitely still something messed up in my math. And partially there's maybe like an identity crisis a little bit, like do we want to be counting the 10 pixels there? And I think we do, but I'm also not sure, because like what should happen if red was negative? Then does our gray box get bigger since red is further to the left, or does our gray box stay the same size since our red box is outside of it? In this case, our gray box got bigger, I think, but it's actually hard to tell, right? Because it's off the screen, and if we scoot it on the screen, we're actually also running into whatever bug is affecting it because of XY, so we're not even sure if that's the same size box anymore. So there's like, I gotta probably figure out what I want it to do. What should it do when one of these things is at a negative coordinate? My initial idea was just always give me the smallest bounding box that contains the children, but the problem with that is I've been talking about this 10-10 offset here, which is moving us down from the corner, which like we're messed up for other reasons right now, so this is not necessarily accurate representation, but it's close enough. I've been talking about this being 10-10, which means red should be down from here and we should have this margin. But then we kind of treat it unfairly in a way, right? Like we have the margin on the left and the top and not the bottom. So maybe we do want to actually... we do actually want to cut it off? I don't know. That's something to think about, and I think that this is probably around where my bug is at. My code is kind of half-heartedly was trying to account for it. I've commented it out at this point, but I suspect I still don't think I have my logic probably right. Somehow we need to bring these back in, but it's not like we were doing with this, so I don't know. Got to figure it out. But that's going to do it for now. I hope everybody has a good rest of your Saturday and rest of your weekend and all that stuff. I probably will be back streaming a bit on Monday. but I don't know exactly what time. So you can follow me on Twitch if you want notifications for that. Yeah, that's probably the best way to do it. So until next time, I hope you have a nice day, and I'll see you later. Polygons, bounding boxes, just to dream the impossible. Yeah. So one thing that I haven't even approached yet with this is vector IO. Like vector IO is like a third type of thing, which we haven't touched yet either. So that will have to be implemented eventually as well. Yeah. But alrighty, I'll see y'all later.